In section 2.5, you're going to be graphing linear inequalities in two variables. So I want you to be able to graph linear inequalities on the coordinate plane and to solve problems using linear inequalities. So let's talk first what a linear equality in two variables is. It relates two variables using an inequality symbol, such as these. You've used those before. And a boundary line is a line that divides the coordinate plane into two regions. So let's look at some differences between graphing linear equations and linear inequalities. With a linear equation, you just, if it's in slope-intercept, you graph the y-intercept, and then you use the slope, and then you draw the line, and that's it. With linear inequalities, you have to decide if the line is dashed or solid, and if you have a less than or greater than, for the inequality, the line is dashed. If you have less than or equal to or greater than or equal to, the line is solid. You can kind of think of the underlines in the symbols less than or equal to, greater than or equal to, as representing a solid line on the graph. The second thing that's different between a linear equation and linear inequality when you graph them is instead of just graphing a line, you have to decide where you're going to shade, either above or below. And you can kind of, if you remember back, if you're solving equations, you have just x equals 3. So you would just have a point on the number line. But when you go to x is less than 3, you're going to refer to all the numbers that are to the left of that as well. So that's kind of like when you're graphing linear inequalities. All right, here's the first one we're going to graph. And I pointed to the inequality because that tells you if you are dashed or solid. So let's first talk about graphing the line. If you look at the inequality, you have, on your paper you don't have this 1 in front here, but this is just an x. I put it there to show you that it's 1x, so your slope is 1. Slope is 1, the y-intercept is 2. And then because of the inequality with the line under here, the boundary line is going to be solid. And when you go to graph it, your line is going to cross the y-axis at 2. It's going to have a slope of 1, so up 1 over 1. There's your line. And again, it's solid. Now we want to figure out where we're going to shade. So what you can do is you can go to the y-intercept and look at the inequality. This is less than or equal to, so you can think of less than being low or below the line. Or you can go right here on the y-intercept and ask yourself, where are the numbers less than 2? Above or below? Well, the numbers less than 2 are below. So we would shade everything below our boundary line. And I want you to take your lines all the way across your graph and shade all the way across your graph, because all of these are solutions. So no short little stubby lines like this. You want to go all the way across. You're going to cut the plane right in half. Okay, now the next one you have is graphing with the x and the y intercepts, and you want to be very careful here, and I'll show you why after we do our example. You're finding x and y intercepts, so again, reminder, x and y intercepts. If you want the x-intercept, you can just cover up the y. So that's going to give us a negative 3x equals negative 1. And when I solve that, I'll get x equals 1/3. If I'm solving for the y-intercept, I cover up the x. And so for this one, just y equals negative 1. So if we go and plot these on our graph, we need to decide, again, if our line is dashed or solid. And because there's a line here, it's going to be dashed. It's going to be solid because of the line there. And we're going to go ahead and graph it. So it's going to cross the x-axis at 1/3, and it's going to cross the y-axis at negative 1. That looks a little bit more than 1/3. Looks almost like 1/2, but we'll just say go ahead and draw the line. It's solid, and now we need to decide where to shade. Now, with graphs that you're using the x and the y intercepts, you want to be very, very careful, because think about what would happen if we would put this in slope-intercept form. if we would have to divide by a negative number to get the y by itself, that would reverse the inequality. So what you want to do instead of using the technique that we use for the slope-intercept is we want to use test points. And the best one to use is 0, 0. Unless it's on the line, then you have to choose something else. So I'm going to choose 0, 0. If the test holds for 0, 0, it's going to hold for all of the points on this side. So if it's true for one, it's true for all. If it's false for one, it's false for all. All right, that means we're going to substitute 0 in for x and 0 in for y. So that's going to give us negative 3 times 0 plus 0. And the question is that we're asking ourselves, is that less than or equal to negative 1? Well, if we simplify that, we have 0 is less than or equal to negative 1. Is that true or false? Well, 0 is not less than or equal to negative 1. So that means this point that we chose is false. So if it's false, all of the other ones are false. So that means our solutions are going to lie on the other side of the boundary line. Okay, now let me show you why you want to be careful with the x and y intercepts graph. If I had this question, 3x minus y is less than or equal to 1, you might say, oh, it's less than, so we're going to shade below. Well, what happens in the process of solving it, so minus 3x, we end up with a negative y is less than or equal to negative 3x plus 1. And then when we divide by a negative 1, we have to reverse this inequality. So what we end up with is y is greater than or equal to 3x minus 1. And this is actually greater than. So be very careful when you're graphing with your x and the y intercepts. Use the test point of 0, 0. All right, you have 2 questions on the other side for you to work on.